Welcome to video 2. Next we have the secant graph. Let's remember the relationship between secant and cosine. Secant of x is the reciprocal of cosine of x. As a result of that, whenever cosine of x is 0, then we're going to have 1 over 0, which is undefined. And so at those places, secant will be undefined. So this red dashed graph is the cosine graph. You can see that it has zeros here, and here, and in each of these places. For that reason, it's going to have asymptotes at those places, because the graph is going to be undefined in those locations. And here. Yeah, all too often disappear on me, don't they? I found that if I make them a little curved, then sometimes it'll take it. So we draw in those asymptotes. Then what we've got is we have curves, which look kind of like parabolas, which constitute the actual graph of secant. So I'm going to do them in gray. Make it a little thicker for us to see. So we've got basically U-shaped graphs that jump off the tops and the bottoms of the cosine graph. You see that? All the way along. And so we're going to have an infinite number of such curves because the cosine graph goes infinitely in both directions. Now let's see the period of the graph. I see that the graph sort of repeats down here, but it repeats as a reflection. It doesn't actually repeat until we get over here. And so from here to here, that's a little above 6, about 6.28, which is 2 pi. And so the period of the secant graph is 2 pi, which is actually the same period as its related cosine graph. Next for the domain. The domain is going to include all real numbers, but we've got these asymptotes going on, which prevents x values from happening in those locations. So it's going to be all real numbers, except pi over 2, 5 pi over 2, and 9 pi over 2, and so forth. It's going to be all real numbers except pi over 2 plus all the multiples of 2 pi. Actually, check that. It's going to be all the multiples of pi. Because we've got, this is actually pi over 2, and this number is 3 pi over 2. It's about 4.7. And so that's a distance of pi units in between those, pi units in between these, pi units in between these. So it's going to be pi over 2 plus all the multiples of pi, which will look like pi times k, where k is an integer. Now the range. The y values, there aren't any y values in between 1 and -1 for our graph. The only y values start at 1 and then go up forever up, and then start at -1 and go forever down. So these y values for the range include negative infinity to -1. And since it includes -1, we need to draw a bracket there. And starting at 1 and going up towards infinity. Next, cosecant graph. Cosecant graph is kind of like the secant graph. It's got a relationship with one of our more familiar functions, which is the sine function. Wherever the sine is 0, cosecant is undefined. And so cosecant will be undefined here at 0 and at pi, and let's undo that. And at 2 pi and so forth. All these places, it's going to be undefined. And so you'll need to draw in asymptotes in each of these spots. I'm going to pause the video to do that. Now, to save you a little bit of time, I just finished drawing the rest of the graph. It has U-shaped curves that jump off the tops of the sine graph and jump down from the bottoms of the sine graph. It takes 2 pi units for this graph to repeat. And its domain is going to be all real numbers except zero, pi, 2 pi, 3 pi, and so on. So all real numbers except 0 plus all the multiples of pi. All the multiples of pi. And the range will be the same as it was up here. Last one, we need to sketch a rather complicated cosecant graph. To do that, we're going to sketch the related sine graph and then have these peaks, these U-shapes, bounce off the tops and the bottoms. So first off, I see that my amplitude is 2. Midline is y equals 1. And then this period is going to be 2 pi over 2. If we do the keep, change, and flip, we're going to see that we have a period of 4. So for the sine graph, draw in your midline. Since it's a sine graph, it will start at the midline, and then go up, and then hit the midline, go down, and hit the midline again. It's going to take 4 units to complete a full sine cycle. So I'll start here and end 4 units to the right of that. Halfway through the sine graph, it hits the midline, has an amplitude of 2, so a quarter of the way through the graph. It's going to go up 2, and 3/4 of the way through the graph, it's going to be down 2. And so we'd start by doing this one. And then since the period is 4, we can do this whole process again. Same over here. And so the asymptotes for the more complicated cosecant and secant graphs will be located at the spots where the sine graph crosses the midline. So in this case, the asymptotes would be located under the asymptotes in red, about here, here, and so forth. We'll draw on those asymptotes. Then finally, we'll put them in blue, we'll draw our U-shapes. Do that. That's a pretty ugly U-shape. It's a little easier to have drawing control with a pencil than with this stylus got going on. This is what your graph will look like here. It's y equals 2 cosecant of pi over 2 times theta plus 1. And that's what I have for you for the lessons in this unit. I'll see you back in class.